Hello all, welcome you all to this channel of V-Square Training Consultants, and in this video we are going to see the shorter method and strategy to find the units digit of any exponentials or a series of numbers, multiplying numbers. So let's get into the video. So what is meant by unit digit? So the unit digit of any number is nothing else but the number in the ones place. That is, the rightmost digit will be the unit digit. For example, if we take 243, 3 will be the rightmost number. So 3 is the unit digit or number in the ones place indeed. Again in 39, 9 will be the unit digit. Let's find the unit digit of the following. So 2 into 14. So this is a very simple example where 2 into 14 is just 28. So you can directly take to 8 as your unit digit, or you can also try calculating by multiplying the unit digit of both the numbers. That is, unit digit of the first number is 2, the unit digit of the second number is 4. So I multiply 2 into 4 to give me 8. So the next one, again here 356 into 3, I don't need actually to multiply the entire number to find the unit digit, wherein I can just multiply 3 into 6. So 3 into 6 gives me 18, so 8 will be the unit digit. Now remember 1, that is, since it is 18, you cannot expect 1 to be the previous number of it. That's not possible. May not be in all the cases, but for sure 8 will be the number that comes in the unit digit. So the next example is 5 into 9934. So again I can just multiply 5 into 4 to give me 0 as the unit digit. 567 into 4432. So I'll do the same. So I'll take the unit digit of the first number being 7 and the unit digit of the second number being 2. So 7 into 2 gives me 14. So 4 is my unit digit. Let's again try to calculate the unit digit of the following. Here it comes. No, it is a series of multiplying numbers. So now I'll again do the same strategy here. I'll apply the same technique here. So I'll just take the unit digit of all the numbers, multiply them to get the unit digit of this whole multiplication series. So unit digit, the first number is 2 and the second number is 3, the third number is 4, the fourth number is 7 and the fifth number is 9. So we just have to multiply these numbers to get the unit digit again. So 2 3 gives me 6. 6 into 4 is 24. So again in 24, I'll only consider 4. I'm just consolidating only the last digit and then taking them forward. So I repeat, 2 into 3 gives us 6. 6 into 4 is 24. 24. I'll take 4. 4 into 7 is 28. So again 8 from that. 8 into 9 is 72. So only 2 from that. So the last digit of this number will be 2. You can also multiply these numbers either on your own or take the help of calculator and then check if your last digit is just 2 and post it in the comment box indeed. Yes. So the next number is a bit big number, which is 444 raised to 444 and 777 raised to 777. So not necessary that this has to be 4, that is the unit digit of this number has to be 4 and the unit digit of this number has to be 7, so that you can multiply these two to get your unit digit of this whole exponential. That's not possible. So we will have to find out the unit digit of this number, find out the unit digit of this number and then multiply. So let's see the strategy to find the unit digit of such exponentials. Here it comes. So you will have to express any given number in the form of x, y, z to the power n, where the whole story depends only on z and n. For example, if I'm going to take the same examples as in the previous slide, 444 to the power 444. So the value of z will be the last digit of your base, that is 4 will be the value of z and the whole number in the power will be n, that is 444 will be n. Got it? So the base's last digit will be z and the number in the power will be n. So the first step that you have to do is divide n by 4 to find out the remainder. Any number on dividing by 4, you get a possibility of 4 remainders. Of course, as you all know, remainder can be 0, remainder can be 1, remainder can be 2 or remainder can be 3. So on dividing n by 4, if you get a remainder as 0, you will have to look out for z. So if z is even, so in this case it is even. So same way, if z is even, the last digit will always be 6. And if it is z is odd except 5, the last digit will always be 1. And then it is very simple to solve it. So if your remainder is 1, the last digit will be z. If your remainder is 2, the last digit will be z square. And if the remainder is 3, last digit will be z cube. So let me also give you a small tip here. So the number in the power is your n and you are dividing n by 4, isn't it? Now let's rewind the divisibility rule of 4. As in the divisibility rule of 4 says, the last two digits has to be either 0, 0 or any number which is divisible by 4, right? The divisibility rule of 4 says the last digit has to be either 0, 0 or any number which is divisible by 4. Now let us take one example. I'm going to take 123. So 123, if I'm going to divide by 4, I get 30 as my quotient, 120 it goes, and I'll get 3 as my remainder. Whereas if I'm going to take just 23 and divide them by 4, so 23 divided by 4 gives me 5 fours 20 and the remainder as 3. So I believe you must have got my point by now. So if I'm going to take either the 3 digits or only the last 2 digits of this, I get the remainder same. The quotient may differ, but the remainder will be same. The same is your application of your remainder rules. I mean your divisibility rules. So if you take, it can be a 3-digit number, that is the value of n can be a 3-digit number, 4-digit number, 5-digit number, 6-digit number, or n-digit number. Whatever be the number, you can just consider the last 2 digits divide by 4. The quotient will vary, but the remainder will just be the same. So we can directly consider only the last 2 digits and then divide by 4. Let's get into the example and try solving the same. So here we have the same example, 444 into 444. So by now I believe you must be able to solve. So the value of n is last 2 digits of the number in the power, so just 44. 44 divided by 4, of course my remainder will be 0. So if my remainder is 0, I look out for is it is even indeed. So the last digit of this will be 6. So here it will be 6. Then let's consider this 77 divided by 4. So when I divide 77 by 4, if you can closely observe, I do not bother about the quotient at all. So 4 it goes, I have 3, then 7, so I'll take 36, so my remainder is just 1. So since the remainder is 1, I'll look out for this option. If my remainder is 1, the last digit will be Z. So Z is 7 here, so I'll directly take 7 here. So 6 sevens gives me 42, so 2 will be the last digit of this complete exponential service. That is 444 raised to 444 into 777 raised to 777 will give us 2 as the last digit. That is a unit digit. Now you must be wondering, see, we took some number, random number, which cannot be calculated even through a calculator, and then we are solving that. So in order to compensate, let's take any number that we can easily calculate. So as you all know, 2 power 8 is 256. So if I'm going to raise a question, what will be the units digit of 2 power 8? Everybody can answer that the answer will be 6. That is the unit digit of 2 power 8 is 6. Let's try solving this using the strategy. So I'm just going to consider z power n where z is 2. So where z, let us put it in a different color. So where z is 2 and the value of n is 8. So the first step that we have to do is divide n by 4. So n dividing by 4, 8 divided by 4, your remainder will be 0. So if your remainder is 0, then you'll have to look out for z. Z is odd or even? Of course z is even. So if z is even, it has to be 6. As in the table says, the unit digit has to be 6, which is just that we have, calculated, proved, it's already there. So same way you can try for 2 power 9 also. So 2 power 9 is just going to be 512. So if I'm going to raise a question, what will be the units digit of 2 power 9? Now all of you can answer that the answer will be 2. That is, the number will be, the unit digit of 2 power 9 will be 2. Same thing we can apply with let's say z power n. I'm putting it in a different color again. So z power n, as you all can clearly visualize, the value of z is 2 and n is 9. So again I'll divide n by 4. I get a remainder as 1. So 9 divided by 4, I get a remainder as 1. So since the remainder is 1, it has to be z. That is, the last digit has to be z, which is nothing else but 2. Right? I believe you must all have been, this concept should have convinced you. Now let's take an extra mile. What if I give you a number like this and ask you to find 645 raised to 644. So the value of n is 44 and the value of z is 5. So this is n and this is 5. So n divided by 4, 44 divided by 4, the remainder will be 0. So since the remainder is 0, we'll have to look out for z. Z is odd but except 5. So in this case, what can we do? It's quite simple. See, 5 power 1 gives you 5. 5 square gives you 25, which is just 5 in your units place. And 5 cube is 125. Again 5 in your units place. And 5 power 4 is 625. Again it is 5 in your units place. So this tells you that 5 power any number, it can be any number under the sky, n number of digits. So any number gives you only 5 in your units place. So if you have the value of z as 5, you can directly write the answer as 5. That is, the last digit will be 5. You need not go for any kind of tabulations, divisions, nothing, and you can just give the answer as 5. So we'll call 5 as one of the probably magical numbers. And there are three other magical numbers when it comes to the unit digit concept. If you can guess, maybe you are right. Yes, so 0 is 1. If you have the value of z as 0, the last digit will be 0. If you have the value of z as 1, the last digit will be 1. Again, 1 per anything gives you only 1 in your units place. There's one other number which is, yes, it is 6. So if you have the value of z as 0 or 1 or 5 or 6, you need not go for any strategy. You can directly write the answer as 0, 1, 5, 6 respectively. If z takes the value of any other number other than these four, then you can adopt the strategy to find the number in the units place. Again, why would I divide it by 4 and not by any other number? Probably you can just think and post your answers in the comment box indeed. Let's just take a couple of examples and solve. So here, I'll go with example 3. Let me directly take example 3. 445 raised to 975. So this, you can directly say that the answer, that is your last digit, will be 5 because the value of z is 5. So here I have 32. So 888 raised to 932. So 32 I divide by 4. So the value of n is 32 here. I divide it by 4. I get a remainder 0. So since my remainder is 0, I look out for z. Z is even. Z is nothing else but 8, which is even. So I'll directly take this will be 6. So 5 into 6 gives me 0. So the unit digit of this value is 0. We can also calculate the answer for this fourth question. So again, 244. I see here you may not even need a pen and a paper to solve. So you can directly give the answer. 44, value of n is 44 divided by 4, your remainder is 0. So this is even. So it will be 6 into, again 66 divided by 4. So 66 divided by 4. So you can adopt the same strategy, just 4. So it gives you 2, 26, so 24. So your answer, that is your remainder, will be 2. So since your remainder is 2, the last digit is z square, that is 4 square 16. So it is 6 again. Into 6 per any number, it is actually 6. 366 raised to 122. 6 per any number also gives you 6 only. So the answer, that is your last digit, will be 6 indeed. 6 into 6 is 36. 36 into 6 is again 6. So you can calculate the other questions here, the other numbers here, that is question number 1, 2, 5, 6, 7 and 8. Give me the answers and also tell me how long did you take to solve this. Post your answers and the time that you had taken to solve in the comment box. Thank you for watching.